So in the last lecture, just a minute. So in the last lecture, we have discussed the LS coupling of the helium atom. So I am sharing the screen where we have stopped yesterday. So yesterday we stopped here. Okay, what is the LS coupling of the helium atom? I'm just repeating one or two steps. So here, if we say that in the helium atom, let's say 2 electron system. So here, in this case, if in the helium atom, both electrons in the n is equal to 1 s2 orbital, its angular momentum of both electron is 0. The spin of both electron is 1/2. So there are two possible term values. One is the 3s1 and other is the 1s0. The 3s1 term value is not possible because if we consider the 3s1 values, both electron spin will be in the upward direction. So as a resultant, all the four quantum numbers of both electron will remain same. So according to the Pauli-Exclusion principle, no four quantum numbers of any two electron will be the same. So as a resultant, the 3s1 level is not possible. So therefore, the ground state of the helium atom is 1s0. So here, the term value of the term value, therefore the both values are not possible. So the term value for the ground state is 1 is 0. So now again the question is that if one of the electron is excited from n is equal to 1 to n is equal to 2 here. So in the n is equal to 2, there are two orbitals. One is the s orbital and other is the p orbital. Now, if the electron is in the s orbital in the n is equal to 2 state, then this is in the s orbital and the lower is in the s orbital. So again, the SS combination. So the SS combination is the similar as S2 combination. So it means what I told you in the last lecture, the LS coupling and its term value does not depend upon the n value or principal quantum number. This value depends totally upon the orbitals. So as a resultant, यहाँ पे अगर आप ये देखें कि this is in the s orbital, this is in the s orbital. So as a resultant, both are in the s orbital. So again, the term value will be 3s1 and 1s0. So now here in this case, the both levels are possible because the 3s1 is also possible, the 1s0 is also possible. Now in this particular case, because the n value is different, because one of the electron is in the first n is equal to 1 and other electron is in the n is equal to 2. So therefore both levels are possible. This is what we have discussed yesterday. So here this shows that the both levels are possible. So 3s1 is possible, 1s0 is possible because one of the electron in the s orbital in n is equal to 1 and other electron in the s orbital in the n is equal to 2. So then we have discussed the p orbital. So now here in the n is equal to 2, there are two orbital, one is the s and other is the p. But if the electron is in the p orbital, then the term value will be different, because now first electron is in the n is equal to 1 s orbital, the second electron n is equal to 2 p orbital. So the angular momentum of first electron is 0, angular momentum of the second electron in the p orbital is 1. So the total angular momentum is 1. So therefore the term value in this case, which we have discussed, is 1p1 and 3p012. So here are, these are the term values for the combination if first electron is in the s orbital and other electron is in the p orbital. So this is the term value here, 1p1 and 3p012. So now in the n is equal to 2, there are only 2 orbitals. But now if we say that the first electron is in n is equal to 1 and the second electron is not in n is equal to 2, n is equal to 2 is not there, the third electron is n is equal to 3. So now in n is equal to 3, it means this is the second excited state. अब अगर इलेक्ट्रॉन इस सेकंड एक्साइटेड स्टेट में है तो इस सेकंड एक्साइटेड स्टेट में हमारे पास 3 ऑर्बिटल है. पहला s ऑर्बिटल है, दूसरा p ऑर्बिटल है, तीसरा d ऑर्बिटल. अगर हम कहते हैं कि इलेक्ट्रॉन s ऑर्बिटल में है तो अब जो लोअर इलेक्ट्रॉन है ये n is equal to 1 वाला, वो भी s ऑर्बिटल में है, और ये जो n is equal to 3 वाला है ये भी s ऑर्बिटल में है. Again the combination is ss combination. So in the ss combination the term value is again 3s1 and 1s0, and both levels are possible because this is in n is equal to 1 and this is in n is equal to 3. So again the both levels are possible. The second thing is that if the third electron is in the p orbital here, so again the first electron is n is equal to 1, the second electron is in n is equal to 3 in the p orbital. So again the combination is sp combination. First is in the s orbital, second is in the p orbital, because the term value doesn't depend upon the n value, it depends upon the orbitals. So the combination is again 1s1 and 3p012. Now if we say that if this third electron is not in the p orbital, but if this third electron is in the d orbital, because in this third n is equal to 3, the electron may be in the s, maybe in the p, maybe in the d. So if this electron in the d orbital, then what happens, which we have to see here. Here, if we look here, the first electron here is in n is equal to first, n is equal to 1, which is equal to s orbital. The second electron is n is equal to 3 in the d orbital. So here L1 is equal to 0, here L2 is equal to 2. So L1 is equal to 0, L2 is equal to 2. So the total angular momentum is 2. So D is equal to 2. So this is the D orbital. Similarly, spin 1/2 gives you the total spin 0 and 1. If we add them, gives you 0. If you subtract them, gives you 1. Parallel and anti-parallel spin. So now here the term value is, because this is the D orbital, this is the d orbital. So in this d orbital, the term value is equal to this d. This d is its orbital. Instead of L, we write it at an orbital, and this is the d orbital. So now n is equal to 2 here. This is L is equal to 2. So this L is equal to 2, and in the first combination, we say L is equal to 2 and spin is 0. So if we take that spin is 0, put it here, 0, 2, 0 gives you 0 plus 1 is equal to 1. So this multiplicity is equal to 1. So now come into the J value here. This J value is equal to 1. J value is equal to 2 plus minus 0. Because spin is 0, L is equal to 2. J value is the plus minus combination of L and S. So this J value is equal to 2 plus minus 0 is equal to 2. So here the total J value is equal to 2 here. Similarly, now in the second combination, this is the d orbital. This is the d orbital, means L is equal to 2 and spin S is equal to 1. So again, when we put it, spin 1 here in the multiplicity, 2 multiplied by 1 gives you 2 plus 1 is equal to 3. So this is called the triplet. So this is called the 3. And orbital is a d orbital, so we call it as a d orbital here. So now here, just a minute. So now this is the d orbital. So here if we put it, j is equal to 2 plus minus 1 is equal to 1, 2, 3. So now j is equal to 2 plus minus 1 is equal to 1, 2, 3, because 2 plus 1 is equal to 3, 2 minus 1 is equal to 1. So the series varies from 1, 2, 3. So here the term value is equal to 3D, this 3D, 1, 2, 3, because in this course, this is the triplet, spin is equal to 1, spin 1 shows that both electron is in the same direction, whose spin is in the same direction, either both is moving clockwise or both are moving anti-clockwise. So the combination is 1D2 and 3D, 1, 2, 3. So now if we conclude this whole story, we say that there are possible term value if first electron is in the s orbital in the n is equal to 1 and second electron is in the d orbital n is equal to 3. The term values are this. These are the possible term values here. So the electronic configuration, this is the term value for this electronic configuration is 1D2, 3D, 1, 2, 3. So now we draw the energy level diagram here. So here, if we look here, this is the n is equal to 1, lower level, this one. This is n is equal to 3, second level. This is n is equal to, for n is equal to 2, this is n is equal to 3, third level. So now here, we say that if we look here, this is the s orbital, this is the p orbital, and this is the d orbital. So I just put it here. If electron is n is equal to 1 here, electron is n is equal to 1 means both electrons are in the 1s0. So both electron is in the 1s. So this combination is 1s2 electronic combination. So the term value is 3s1 and 1s0. So here in this case, this 3s1 level is not possible, what we have discussed. So this can be removed. The ground level is equal to 1s2 is equal to 1s0, because 3s1 level is not possible. So only the possible level is 1s0. Now the second come to n is equal to 2. In the n is equal to 2, if the electron is in the s orbital here, s orbital, then these are the two possible values. The first electron is 1s1, the second electron is 2s1. The possible term values is 3s1 and 1s0, because both levels are possible according to the Pauli exclusion principle, because all four quantum numbers are not same here. Because one of the electron is in the lower state and other electron is in the n is equal to 2 state. Both are even s orbitals, but again these both levels are possible because the principal quantum number n quantum number is different. Even the orbital is same. Now if we say that n is equal to 2, electron goes into the p orbital here. If it is in the p orbital, the energy levels are these, which we have discussed earlier. So the 3p0, 3p1, 3p2, 1p1. So these are the energy levels here. So this is the electronic configuration. First electron is in the s orbital and the second electron is in the p orbital, n is equal to. Now come to the n is equal to 3 here. If the electron is in the s orbital, so now in the s orbital, again the term value is simple. The 3s1 and 1s0. Why both levels are possible? because the first electron is in n is equal to 1. What we have written here, 1s1 and 3s1, because one of the electron is in the s is equal to 1. So 1s1 and the second electron is 3s1. The principal quantum number is again different, so therefore both levels are possible. If we look here, if in the p orbital the energy levels term values is the same as which we have discussed. Now if n is equal to 3, now in the n is equal to 3 here, in the d orbital, the first electron is in the s orbital and other electron is in the d orbital. So as a resultant, we can say that the possible term values is equal to 1d2 and 3d, 1, 2 and 3. So these are the possible term values here. So now we have to look at that. This is the energy level diagram. So now we have to look at the transition of these energy level diagram. Here is the LS coupling of the orbital. What we have discussed, if both electron in the s orbital, the term value is this 3s1, 1s0. If one electron is in the s orbital and other electron is in the p orbital here, this is the both electron which are in the s orbital. We have seen that the term value is this. This is the term value. If the one electron is in the s orbital and other electron is in the p orbital, the term value is this. This is the term value. If one electron is in the s orbital and other electron is in the d orbital, the term value is this. If one electron is in the s orbital and other electron is in the f orbital, अब f orbital कहाँ पे होता है? f orbital होता है n is equal to 4 में. n is equal to 4 में 4 orbital होते हैं, s, p, d, f. So अगर f में है तो आपकी term value ये हो जाएंगे, आप करके देख सकते हैं. So generally these are the term values for the different orbitals, orbital combination of the two electron system here. So now again, if we draw energy level diagram for this value, if we look here, if I put it here, a new slide, how the electron jumps from lower level to the higher level here. If we say that this is the combination of n is equal to 1 and n is equal to 2, what is the transition here? यहाँ पे transition कैसे हो सकती है? अब हमें इसकी transition देखनी है. किस तरह देखनी है? देखें आप अगर, if we look here, how to draw a transition here? These are the levels. These are the levels electron jumps from n is equal to 2 to n is equal to 1. It emits out the photon. Now in the transition here, we have to follow the selection rules. And we call this selection rules is the dipole transition rules. And which we have discussed in our previous lectures here. So if you look here, what are the transition rules? The transition rules are delta L must be equal to plus minus 1. delta S must be equal to 0 and delta J must be equal to the 0 or plus minus 1. 0 or plus minus 1. So this is the selection rule for the transition. These are the selection rules for the transition here. So it means the electron de-excite from higher levels to the lower level, it follows this transition rules. If it follows this transition rule, then that transition is possible by emitting the photon. If the transition is not following these rules, again we can say that the electron is again de-excited, but in this particular case it will not emit out the photon, and that transition is known as the radiation less transition. So now here, if we say that electron is in the s orbital here, s orbital. अब अगर इलेक्ट्रॉन s ऑर्बिटल में है यहाँ पे n इज इक्वल टू 2 पे, तो ये तो इसकी सारी की सारी जो लेवल्स है ये इसकी एक्साइटेड स्टेट्स है. यहाँ पे इलेक्ट्रॉन को रहना नहीं है. यहाँ पे इलेक्ट्रॉन सिर्फ स्टे करेगा 10⁻⁻8 सेकंड के लिए, क्योंकि विच इज द लाइफ टाइम ऑफ इलेक्ट्रॉन इन द एक्साइटेड स्टेट. अब इन 6 स्टेट्स में 1 2 3 4 5 6, इन 6 स्टेट्स में इलेक्ट्रॉन कहीं पे भी हो सकता है. अब अगर इलेक्ट्रॉन यहां पे है एस स्टेट में, तो ये वापस एस स्टेट में नीचे ग्राउंड स्टेट में नहीं आएगा. क्यों? कि डेल्टा एल विल बी इक्वल टू 0 एंड डेल्टा एल 0 इज नॉट पॉसिबल. दैट डेल्टा एल मस्ट बी इक्वल टू प्लस माइनस 1. So if electron is in the s orbital in the n is equal to 2, it will not go down into the s orbital into the n is equal to 1. So this transition is not possible. If electron is in the 3p1, अगर इलेक्ट्रॉन इनमें है 3p1 में, तो भी पॉसिबल नहीं है. क्यों? कि अगर आप यहां पे देखें, अगर इलेक्ट्रॉन यहां पे है, थ्री पी वन में है, तो भी पॉसिबल नहीं है. क्यों? कि आप ये देखें कि ये स्टेट्स है, ये भी पॉसिबल नहीं है. क्यों पॉसिबल नहीं है? कि यहां पे अगर आप ये देखें कि इसकी मल्टीप्लिसिटी 3 है, इसकी मल्टीप्लिसिटी 1 है, तो 3 से जब 1 में आएगा तो एज अ रिजल्टेंट जो डेल्टा एस होगा वो प्लस माइनस 1 होगा. क्योंकि मल्टीप्लिसिटी 3 मींस स्पिन 1, हियर मल्टीप्लिसिटी 1 मींस स्पिन 0. तो स्पिन 1 से स्पिन 0 में जब आएगा तो डेल्टा एस क्या होगा? 1 होगा. और यहाँ पे हमारी रिक्वायरमेंट क्या है डायपोल ट्रांजिशन रूल्स की? वो 0 है. तो इसका मतलब है कि इस लेवल से ग्राउंड स्टेट में इलेक्ट्रॉन नहीं आएगा. सो द ओनली द पॉसिबल लेवल ऑफ द ट्रांजिशन ऑफ द इलेक्ट्रॉन इज फ्रॉम this level, which is equal to 1p level, to this level. This is the only possible transition here. So the only possible transition is from only possible transition is from 1p1 to 1s0. Now if we look here in this possible transition here, this is 1, this is 1. The multiplicity is 1, it means the spin of both is 0, so delta S is 0. This is the p orbital, it means L is equal to 1. This is the s orbital, means L is equal to 0. So therefore delta L is equal to plus minus 1. This J value, which is equal to in this case is 1. Here in this case J value is equal to 0. So therefore the delta J is equal to plus minus 1. So this is the selection rules for the transition. So only the transition from n is equal to 2 to n is equal to 1 is from 1p1 to 1s2. So the only transition is from 1p1 to 1s. Only the transition is from 1p1 to 1s0. So there is no any other transition which is possible here. So only this is the transition possible. So now question is that again, if electron is in the s orbital, then how it come back into the ground state? There are two possibilities. The electron can come back into the ground state because electron never stay into the s orbital because this is its excited state. So यहाँ पे नहीं रह सकता, इसको वापस आना ही आना है. अब कैसे आएगा? या तो ये किसी और एटम से कोलाइड करके अपनी एनर्जी रिलीज करे और फिर ये ग्राउंड स्टेट में आ जाए, या दिस ट्रांसफर टू द पी स्टेट. अब ये पी स्टेट से ट्रांसफर हो सकता है बाय फॉलोइंग दिस रूल्स. यहां से आप अगर इस सब के रूल्स देखें कि कहां से कहां तक आ सकता है, तो यहां से ए से उसी n इज इक्वल टू 2 के p में आ सकता है, ये पॉसिबल है. फिर p से यहां पे आ सकता है. अगर ये यहां से आएगा तो यहां पे आएगा. अब देखिए 1p1 में कहां से पॉसिबल है? ये यहां से 3s से पॉसिबल नहीं है. इसका मतलब है कि अगर इलेक्ट्रॉन यहां पे है तो वापस यहां पे आ सकता है. इफ द इलेक्ट्रॉन हियर इलेक्ट्रॉन इज इन द 1p1 इट कैन गो डाउन हियर. यहां पे मैं इसको बड़ा करके दिखाता हूं. अगर इलेक्ट्रॉन ये है, अगर इलेक्ट्रॉन 1s0 पे है तो 1p1 पे आ सकता है. अगर यहां पे आया तो फिर यहां पे डायरेक्ट आ सकता है. फिर ये ट्रांजिशन पॉसिबल है, अदरवाइज पॉसिबल नहीं है. So these are the transitions from n is equal to 2 to n is equal to 1. So now how the transition is possible from n is equal to 3 to n is equal to 2 or n is equal to 3 to n is equal to 1. अगर आप n is equal to 3 से n is equal to 2 में देखें तो क्या कैसे कर सकते हैं हम? Look here. इन चीजों को समझना जरूरी है. अगर एक भी चीज समझ में आ गई तो प्रॉब्लम सॉल्व हो जाएगा. अगर कुछ भी समझ में नहीं आया तो इट विल बी डिफिकल्ट. अब यहां पे हमारे पास दो लेवल्स हैं. फर्स्ट इज n is equal to 3 and other is n is equal to 2. Here the electron can come back from n is equal to 3 to n is equal to 2 by following the selection rules. So now how the electron is coming here from n is equal to 3 to n is equal to 2 by following these selection rules here. अब यहां पे देखें, मैं इसका वो जो है ग्रुपिंग खत्म कर देता हूं. ओके यहां पे हमारे पास ये इलेक्ट्रॉन s में है, ये p में है, ये d में है. यहां पे n is equal to 2 में हमारे पास दो इलेक्ट्रॉन है. तो यहां पे हमारे पास जो दो इलेक्ट्रॉन है उसमें अगर आप ये देखें कि n is equal to 2 में हमारे पास दो ऑर्बिटल्स है, s और p, और n is equal to 3 में हमारे पास तीन ऑर्बिटल है, s, p और p. अब अगर इलेक्ट्रॉन s में है तो s से डायरेक्ट s में आ सकता है? नहीं, यहां मुमकिन ही नहीं है कि n is equal to 3 में n is equal to इसमें आ जाए. मुमकिन ही नहीं है क्योंकि ये भी s है, ये भी s है. तो l दोनों का क्या हो जाएगा? 0 0 gives you 0. तो इसका मतलब है अगर यहां पे है तो यहां पे नहीं आएगा. s to s नॉट पॉसिबल. अगर p में है तो p से p में आएगा? नो. p to p is again delta p is equal to 0. तो p से p में भी नहीं आएगा. तो फिर कहां से कहां जाएगा? ये p से s में जा सकता है एंड d से p में आ सकता है. d से s में भी नहीं जा सकता क्योंकि ये d है. d का मतलब है l is equal to 2. अब L इज इक्वल टू 2 से L इज इक्वल टू 0 में नहीं जा सकता, क्योंकि डेल्टा L प्लस माइनस 2 हो जाएगा, तो यहां से यहां तक पॉसिबल नहीं है। तो अगर मैं ये यहाँ पे ड्रा करूं आपका, तो आपको समझने के लिए, ये क्योंकि आपके पास ये स्लाइड्स रहेंगी, तो मैं आपको यहाँ पे, असल हमारा मकसद समझना ही है, ये यहाँ से यहाँ पे ये जो ट्रांजिशन है